Hello everybody, welcome again to my channel Physics with Argeo. Today we are going to solve the problem 33 of the book Physics, Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Chairperson. The problem is the next. An alpha particle consists of two protons and two neutrons. What is the force between two alpha particles separated by a distance of 2 nanometers? So, the step number 1 is obtain the electric charge of one alpha particle. If we have an atom of the element helium, this circle of pink at the center is the nucleus, and this bigger circle of blue with these two circles are the electrons. The electrons are of purple. But if you quit the electrons, you get an alpha particle. So an alpha particle is just the nucleus, in this case, of an atom of the element helium. So two protons and two neutrons. Like establishes the problem. So the charge of one proton is 1.6 times 10 raised to the power of negative 19 coulomb. The neutron is neutral. It has no electric charge. So it's equal to 0 coulomb. So an alpha particle is equal to 2 times 2 protons plus 2 times the neutron. It's equal to 2 times 1.6 times 10 raised to the power of negative 19 coulombs plus 2 times 0 coulombs. It's equal to alpha equal to 3.2 times 10 raised to the power of negative 19 coulomb. This is the electric charge of one alpha particle. So this is the first one and the second alpha particle, separated by a distance r equal to nanometers. So the step number 2 is use the law of Coulomb that establishes that the electrical force between two electrical charges is equal to capital F equal to the constant of Coulomb K multiplying the product of the two electrical charges, in this case the first alpha particle and the second alpha particle, divided by the distance between they both, r squared. It's equal to 9 times 10 raised to the power of 9 Newton meters squared divided by Coulomb squared, multiplying the electric charge of the alpha particles. 3.2 times 10 raised to the power of negative 19 coulomb, multiplying the second magnitude of orange, 3.2 times 10 raised to the power of negative 19 coulomb, divided by the distance between the two alpha particles. This distance is of 2 nanometers, but nano is equal to 10 raised to the power of negative 9 meters squared. It's equal to 92.16 times 10 raised to the power of negative 29 newtons meter squared divided by 2 times 10 raised to the power of negative 18 meters squared. 92.16 divided by 4 is equal to 23.04. And 10 raised to the power of negative 29 divided by 10 raised to the power of negative 18 is equal to 10 raised to the power of negative 29 minus negative 18. That is equal to negative 11 newtons. Because meter squared divided by meter squared is equal to 1. So, it's equal to 2.3 times 10 raised to the power of negative 10 newtons. And finally, it's equal to 2.3 Armstrong newtons. Armstrong, symbolized with this symbol, means 10 raised to the power of negative 10. So, the electrical force between two electrical alpha particles has a magnitude of 2.3 Armstrong newtons of repulsion, because these two alpha particles have the same symbol, positive symbol, because they are formed of protons. So, students, thank you for your attention. It was the problem 33 of the book Physics Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Chairperson. Thank you for your attention and study a lot.